Hi everybody and welcome to 5 minutes of. In this video I want to talk about a new powerful tool, zOS Authorized Code Scanner or zACS. But this time I probably need more than 5 minutes. Today there is a great attention to the security of every system and also of mainframe. One of the most important points from a security perspective is to preserve the system integrity. But what is system integrity? Well, in general, we can consider system integrity as the state of a system in terms of system functionalities without being degraded or compromised by changes or disruption that could be internal or external. Then a malicious code or a code with bugs can open the door of the system to exposures and vulnerabilities. In particular, on zOS, we can consider the system integrity as the inability of any program not authorized to circumvent or disable store or fetch protection, or to access a resource protected by a security server, or to obtain control in a privileged or authorized state. That means a program that runs with ISPF authorized or in supervisor state, that is a privileged state with a protection key less than 8. And as you know, zOS includes features and facilities designed to protect one program from affecting another program, either intentionally or accidentally. But we also know that system protection involves a number of tasks such as maintenance or system integrity, use of IPF, use of RACF, changing system status, protecting low storage. So we can say that there is no way for an unauthorized program to bypass store or fetch protection, or to bypass password checking, or to bypass RACF checking, and to obtain control in authorized state. Well, in general, it's the responsibility of the installation, system programmer or system administrator, to verify that any authorized program added to the system will not introduce any integrity exposures. To do this, an installation should consider the areas for potential integrity exposures, such as user supplied addresses for user storage areas, or for protected control block, resource identification, SVC routine, control program and user data accessibility, resource serialization, and so on. But all these factors are covered by IPF, storage protection, and cross-memory communication. Just to remember, the IPF is used to allow the installation to identify system or user programs that can use sensitive system functions. To maintain system security and integrity, a program must be authorized by the IPF before it can access restricted functions, such as SVC or special function or program. And typical IPF libraries are linklib, svclib, lplib, and a program in that library can do virtually everything that it wants to. It is essentially an extension of the operating system. It can put itself into supervisor state or system key. It can modify system control blocks. It can execute privileged instructions. It can turn off logging to cover its tracks. In few words, this authorization must be given with attention and monitored carefully. Storage protection. Storage protection is an hardware function used to prevent unauthorized alteration of storage. And it is also used to prevent unauthorized reading of storage areas. It deals only with real memory, not virtual memory. And when a page of virtual memory is copied from disk to a free page into main storage, zOS also sets an appropriate storage protection key in that page of main storage. The protection keys cannot be altered by application programs, so there is no way for a normal application program, a not authorized program, to protect part of its virtual memory from other parts of the application in the same address space. Cross-memory communication. This feature allows a program in one address space to communicate with the program in another address space, thanks to the operating system functions. In this way, users and applications run in different address space and are completely isolated from each other. One possible exception to this isolation is the cross-memory communication. A number of cross-memory capabilities are possible, but the commonly used are two: the ability to call a program that resides in different address space, program call, and the ability to access virtual memory in another address space, fetch and store. Okay, then we can understand how program call and supervisor call provide critical service to zOS. And any given zOS image typically has hundreds of program call and SVC. Some of them are created and maintained by IBM. Others are created by other vendors. And we also have custom code, in-house code, developed internally by the customer. The implementation of PC and SVC routine, then, is to be considered as critical task, because if you use untrusted parameters or if you implement a PC or SVC routine incorrectly, a security vulnerability that compromises the system integrity of your zOS may be introduced. For example, use cases tested in the customer environment are often called risks because they are good opportunities to introduce bugs into the system. Then the question is, what can I do to ensure this integrity? Or what is the potential severity associated with this risk? Then there is a need to discover vulnerabilities that might exist and remediate them before they could be exploited. To do this, now we can use a new tool named zOS Authorized Code Scanner, or zACS, that provides the ability to test PC and SVC and clients authorized code to provide diagnostic information for subsequent investigation as needed. zACS is a new priced feature of zOS version 2.4 that help clients to ensure the security posture on zOS, especially in the development and test pipeline. In few words, zACS is a scanner that is used to search for potential vulnerability in order to avoid potential compromise to the system integrity of zOS. Which are the components of zACS? Well, it consists of started task, a set of recs, batch jobs, and associated datasets, input and output dataset. The started task run authorized, while the tests generated by the recs do not. Both the input and output dataset contain sensitive data, as the input determines the aim of the scan and the output may describe potential vulnerabilities found on zOS and their respective locations. Therefore, this dataset, along with the recs exec, must be protected by an external security manager such as RACF. And you can see in the bottom some definition, some RACF definition for zACS. Okay. How does it work? zACS is run in the following steps. First one, initialize the started task with after the configuration. Run the batch jobs to generate the PC and SVC tables. Run the recs to generate test cases in batch. Okay, it's very simple. First of all, you have to configure zACS. The configuration file can be found in this library as bpn samp in this member, okay? And you need to specify SVC and PC log dataset and other parameters. zACS use mainly two datasets, the bpn PCNAM that contain the list of PC number for the system, and the bpn SVCNAM dataset that contain the list of SVC number for the system. Then you can start the tool, zACS, with your started task using the console command start bpn zACS. Okay. Starting this task will clear the output dataset defined in the started task, including any vulnerability data that was found. The tool set the following sleep, okay, when the task is started. This sleep may override other sleeps set on the system, obviously. And during a test run, zACS intentionally can generate many bands. And for this reason, it is suggested to run the tool into the test environment or development environment. Okay. The sleep will suppress all dump generation while the zACS task is started. The sleep will be removed when the task is stopped. Before testing PC and zACS, you have to run two jobs included in SAMP-lib. The first one is the bpn pcnum to generate PC table. And as PC number can change, this job should be run regularly to ensure the table is updated. Then you can run the bpn svcnm. This is the job to generate the SVC table, and this job needs to run once for every IPL or anytime that the SVC table is updated. To test all SVC and PC program call, you need to run the two recs mentioned here: bpn knsvc, bpn knpcx. To limit the number of services tested in a run, optional parameter may be used when running the recs. For example, you can use the filtering. That is a good option with include and exclude a list of services or modules. Okay. zACS can also be used with ISPF panel, and this is the main panel of the product. And for example, you can test all SVC in your environment, all PC. And if you want to test all PC in the generated PC table, for example, specify option 4, and then you have to specify the R option, R command in the option line at the bottom of the field. Okay. When the R option is selected with test option 1 of 4, a confirmation window will pop up to prevent starting a large run accidentally. To continue with the run, select 1 and press enter. If you want to prevent the run from starting, then select 2 and press enter again. Okay. And this is an output, an example of potential vulnerability output. As you can see, in line 1, there is the service number where the potential vulnerability was detected. And then the line 2 indicates the 6-digit abend code, which allows for user abend when applicable. The line also includes the abend reason code, and then we can read the PSW, okay, in line 3, as well as the name of the module where the potential vulnerability was found, if known, and the offset where the abend occurred. Line 5 indicates the failing instruction translated into assembler format. Okay, here. And line 6, the source of target address that caused the translation exceptions. And okay, line 7, we have the probable zACS score and vector of the potential vulnerability. And zACS score are calculated using zACS version 3.0. The line 8 report the header of for the sample sleep command. 99 provides an example sleep command when one can be automatically generated. And then we have the general registers before the services, the general purpose register immediately before the service was invoked. And here the general purpose registers at the time of error. Okay, just for example. Okay, I am finished. I think that this tool is a very powerful tool that can help us to have a zOS more secure. Thank you for your attention and see you in the next video. Bye bye from Luigi.